Welcome to FireVoxel. I'm going to demonstrate new cardiac output and cardiac output based input function correction dialog. We have an MRI image with several vector OIs. Let's select one of them. Here's the corresponding time activity curve. After we save that time activity curve, we have a time activity curve file. So this works at the moment only in the mode when no document is open. So we go to dynamic analysis menu and choose cardiac output measurement and correction item. And empty dialog box appears. So next step, we load the time activity curve generated in any way from FireVoxel, either with raster OI or vector OI. So we see that the time activity curve is loaded. First, important for cardiac output measurement is to determine the time point where the recirculation starts. And this could be done either manually. For that, you just click on anywhere along the time axis, and the green vertical line tells where the separation is. Or you can just press the button called recirculation, and that time point will be selected automatically. In this particular case, it's a nice selection, so we'll keep it. So next, this dialog box has a dual purpose. First is the cardiac output measurement. To measure the cardiac output, we need to specify the concentration. Let's just choose the very basic concentration. When we press OK, we go to, now everything is displayed in the concentration mode. And some additional curves have appeared. The blue curve is concentration curve of the original signal curve. Additionally, the gamma variate fit is generated automatically, and gamma variate fit is only generated for the based on the time points till the recirculation. The rest of the time points is just interpolated. So we can change the color of any curve by double clicking on the corresponding color box, or we could entirely remove the curve, not remove, to hide it. Curve is present, but we can hide it sometimes, for example, gamma variate. So to measure cardiac output, the next step is to enter the dose. Let's just enter 10. And after the dose is entered, if we press cardiac output button, the cardiac output number immediately appears in liters per minute. So this is the first mode of the calculation. And note that it requires the concentration curve to be displayed as concentration. For example, if you display signal curve and press cardiac output, we get the message that the unsuitable concentration conversion. So let's go back to concentration. So this value is our cardiac output. So this is the first way to use this dialog box. Now, the second way is when we have input function and we have both dose and the cardiac output. And based on the paper from Jeff, we invoke the S0 shift with gamma variate algorithm, and there are no parameters. We just press correct, and at the bottom you can see the execution continues, and the new corrected curve appears. As expected, it completely matches the provided concentration curve, because we used exactly the cardiac output calculated directly. But now let's say usually the cardiac output would be provided by some outside method. So let's change it, say, to 7 liters per minute. Now if we press correct again, the execution starts and the new corrected curve will appear. So you can turn it on and off, and we could now we can display it in the signal values. So you can see that the signal curve was shifted, and also note that the gamma variate curve is only visible in concentration mode. So just perform another basic check. If we not, we can save the corrected curve. So save button applies to corrected curve only. Let's say one save. So if we close the dialog box now and reopen it, now we go to the corrected curve. So let's select again the concentration. Let's select the same dose. And if we press cardiac output, we would expect that number 7 will appear, because that's what the curve was corrected to. And we get a fairly close 696. All right, let me know if this is sufficient precision, and thank you. Let me know if there are any corrections needs to be made. Thank you.